Hello everyone, let's look at the week number 66, and there are a couple of tasks there. Let's look at the first task first. The task is to divide integers, so we have two integer numbers and we have to divide one by another without using multiplication, division and modulo operator, and return the flow of the result of the division. Looks like an interesting task. Well, basically you can replace division with subtraction. The only thing here is that if you have negative numbers, as in these examples 2 and 3, then there's a small problem, like 5 divided by 2 is 2.5 and the floor is 2, but minus 5 divided by plus 2 is minus 2.5, and if you will round it down it will be minus 3, not minus 2. That's the main difficulty here in this problem. And if you divide two negative numbers, well, the negative number by another negative number, you will get a positive number, and it's not 3, it's 2 in this case. But let's look at the solutions that we can find here. The solutions are we're only looking at the Raku solutions. Raku solution, my solution goes first, but I will not look at this first. First, let's look at Luca Ferrari's solution, Raku number 1. Raku number 1, here is the solution. Write the script, yes. So there are two incoming numbers. Extract both the signs. So we first want to take the signs. That's the really necessary thing here. I mean, I'm serious because it will make the further solution a bit simpler, I believe. So if it's more than one, oh wow, nice, interesting. So you have two variables in one my declaration, and you can just compute both. Well, yeah, that's obvious, but I've never seen this. You can compute both values in the same line. Yeah, I believe we can make some function out of that, but okay. Then we numerate the denominator, so it's then we are taking absolute values of those. I believe those operations do not require multiplications and all the forbidden operators inside. Result and reminder is 0 in numerator. Result is 0 first. If reminder is more than denominator, what is remind here? Numerator, so it's, why is it remind? If the second number is bigger than the first one, then we increment the result y and subtract the so yeah, so that's reminder. Yes, basically, yeah, we just, yeah, that's the algorithm, but I saw a plus here and I was a bit confused. So basically we count how many times we were able to subtract the second number from the first number before it gets lower than the second number, right? So okay, so at this point we subtracted everything we could, and this is a sign multiplication. It has nothing to do with computing the result. Yeah. So yeah, so this program computes the sign by using multiplication operator even twice. Well, yeah, I think it's a breach of the task definition, but yeah, never mind. So that's the difficulty of this task. And then you will print the result, taking into account the sign. Let us maybe run this program. cd Luca Raku number 1. Raku number 1. Yeah, the first number is like 5 and 2 as in the task. Oh my god, what is it? Sorry, it's another solution. It's challenge 68 and we need 66. Luca Raku. Right. It's differently. So here you have to specify the input numbers differently. 5, 2, remainder 1. Okay, what if it's -5 and -2 first, which is the simple task? And finally, what is if it's -5 and +2? It's -2. That's the thing I told you in the beginning. Actually, I also solved this kind of incorrectly, like this one. I also have -2 in this case, while in the task it said it should be -3. And for example, what is like this? Yeah, it's the same. The only thing I don't like here is this one, because yeah, it's using multiplication sign even for a helper purpose. Let's go next, and the next solution from Mark Anderson. And here is this solution. So again, there are two numbers. Nice. Where there's a separate condition that the second number cannot be 0. And yeah, maybe actually we don't need this, just where n. You see, nice. This is a really nice thing. I forgot about that. I knew about this, but as you can imagine, Raku is so big that you can sign Raku. Let's save this solution. So you have, for example, the number my n minus 42, and you want to print the sign of it. What is the sign? Raku sign -1. And if it was like m and m plus, it's, I believe it will be 1. The only thing, okay, so what is for 0? 0, there's no sign. Okay. My question is, what was my question? My question is, let's go back to the solution, and okay, let's keep it like this. So we took the signs as plus and -1, potentially in these two variables. Then we run the function. Also notice that you can define a function inside another function. That's a really nice feature. And probably I also have to make a sub Raku, like subroutine A with no parameters, subroutine B, say I'm B, I'm the function called B, and I'm A, right? And you can call function B from here, but not from here. Unlike some other languages, you cannot run Raku, you cannot run this, you cannot access this function undeclared routine, so you cannot do it like this, but you can do it like this, and of course we have to call this function, right? So I'm A, I'm B. These functions work. Nice. So basically it's really handy if you don't want to expose these functions, for example, if you don't need it anywhere else. Here we're passing the copy. It means that we can modify the m variable here inside the program, so something like this. Without this, the compiler would not allow you to change the value that you already passed here. And we're not going to modify n. State variable, it's the variable like static in C++, and it will keep the same value before the call, so we can call it twice, 3 times, and this variable will be there in the same state next time you enter the function. So if the number is positive, so we have 2 different branches for depending on the sign of the initial number. Quotient, we increment this, and we decrement, we subtract the second number from the first one, and we repeat that until yeah, it's kind of until, because it's a recursive call to itself, but in essence this is a loop until m is more than 0. And as soon as we reach the negative thing, the negative side of the axis, for example, if m was positive first and there was some reminder, like in the previous case 5 and 2, then we reach here. If the signs are different, what? minus quotient. What that means is that, well, yeah, I wouldn't do it like this personally, but that's a perfect and completely allowed thing in Raku. Basically, this is the last, because there are no executable code if we reach this place. There's no executable code, and the last computed value is this minus quotient, and it will be the return value of the function. Basically, then you don't need this semicolon. If the signs are the same, then yeah, so if the signs are the same, then we make some, like, we fix this computed value if the value is not 0. Again, equals 0 is kind of optional thing here. But let's run this program. Mark Anderson, not here. Mark Anderson, Raku. Right, so it's 5 and 2. Yes. What if minus minus? Finally, like this, minus 3. And what is like this? Yeah, well, basically, yeah, because we just compare the sign. We don't care which number had the minus sign in this case. Okay, so it works. It's a bit like, it's quite big number of lines here in this solution, but it works as expected, which is really good. Markus Holzer, Raku number 1. Never mind. Okay. Now Allenhover number 1, right? There are some examples. Okay, so yes, and I really like it. So basically, we don't have to run this code with different numbers, input numbers. So maybe I'll just go there. cd back now would Raku number 1 p6. Why p6? Minus 2 minus 3 plus 2 minus 3. Right. Let's see how it works. Tedious div. If absolute value of first number is less than second number, then okay, so then yeah, we just go to, I wonder, so yeah, then we just divide the axis by 4 quadrants, and then this one kind of from the different perspective, looking at the same numbers from different perspectives as these two, but okay. And finally, in these 3 branches, we are calling the same function recursively again, with the number yeah, already, like, we make the first step with the division, the first subtraction. If the numbers has different signs, then we make addition instead of subtraction, right? And we fix this. The only thing I kind of find potentially incorrect, what if we don't have, like, what if there was 6 and 2? Will it be minus 4 in the end? By the way, that's the same question about other programs. Well, Luca, Raku 1. What? Yes, so it's like 5 and 2 was oh my god, right. What if, for example, it was 6? Here it's 3, but what if it's minus 6? It should be minus 3 but not minus 4. And who was the previous solution? Mark Anderson, right? Raku. So it's like 6 and 3 and minus 6 and 3. Minus 2, that's correct. That's completely correct. Okay, let's go back to node. Raku, node, Raku. Yeah. Maybe I want to modify this one. And for example, here we'll have, well, here 6 is not that really that interesting. Oh my god, that's Vim. 6. Here is 6. here is 6, and yeah, this one is actually not that. No, this one is interesting. 6, right, save it. Raku Ch1 tail Ch1, so it's +3 -3. Okay, wow, nice. So it works correctly even despite all this stuff. But I believe if ups m, yeah, so this is the case when the first number is less than the second number, so the result is always 0 for positive numbers, and -1 for negative. Okay, this is the branch, right? So yeah, I'm still kind of curious why we always have to subtract 1 in this case and add 1 here. Probably because we start with 0, but yes. Shahid, number 1. A different solution. I mean, there's just one liner in a loop. If n is 0, so yeah, that's also possible. It's not like the program accepts this, but throws an error immediately. We make the absolute, we take the absolute values of both, and then this is the result. Obviously, we just increment the result until, well, while this is positive or 0. Notice the use of an Unicode version of this operator. Really nice feature of Raku. I wondered if there's like ++, the possibility to make some Unicode thing. And yeah, and I also would like to have like a Unicode character for say, for printing, like some I don't know, yeah, speaker. Then yeah, that's a nice thing. This XOR operation, exclusive OR, basically, yeah, it gives us the sign. So if the sign is different, then it's -1. We add -1, we subtract additional 1 from the result and negate the result. Otherwise, if the signs are the same, we just print the result. I like this solution, by the way. Let's go Shahid, the Raku Ch1, 5 and 2, -5, right, and 5, like 6 and 3. It will be, that's incorrect, because it should be -2, right? Like -10 and 5 is -3. This is incorrect. I mean, this is wrong. That's what I was thinking about in the previous solution, which was correct. Okay, Ulrich Rike, Raku number 1. Yes, I like how he solved the thing with printing 0-1 strings. Dividing and subtracting repeatedly. First we operate in absolute numbers, then we differentiate by different signs. So yeah, my divide. So let's start with the main function. It just passes the control flow to my divide function with no changes of the numbers. It returns an int. Honestly, I don't know if I like this. On one side I like it, on the other side it looks a bit strange for programming language based on Perl. But yes, it's possible, and it really gives you information about what you can expect in this program. I hope the compiler also can use this. So again, absolute values of the numbers. 0 if the first number is less than the second number. The absolute, right? First num, second num, yeah, these are the absolute. So here we use A and B, and here we used first and second for some reason. And if they are equal, you give immediately 1. And finally, the most common case, right? And what's this then? The first number is more than second number, unless this is a separate, so it's not connected to this if, right? So okay, so we take this count, which should be the result, I thought, but it's not the result, because it's a negative. It's a result without this 1. Why do we need 1 there if you will just decrement this in the end with the prefix minus minus? Number is the second number, and while this second number is less than the first number, you can plus so see, wow, so it's not subtracting the number from the first number, it's trying to add the second number to itself as many times as possible to reach the first number. Wow, that's again, so this is what I told you in the beginning. So the way of thinking here is different from what I would expect. The only thing I don't understand is why you decrement here, because what if you just put 0 here? Will it change anything? Okay, so we reach this point. We do not return from this if, and unless same sign, so the same sign is a helper function with the Boolean result, and obviously it gives us true if the signs are the same, including 0. For 0 we will get true. So if the signs are different, then again we use multiplication operation here to change the sign of the result, which is actually you can just print the character minus in Raku, right? If absolute isn't 1, then result decrease by 1. No idea what this does. The idea is to get -3 if you divide -5 by 2. But let's run this, including the edge cases like 6 and 3. Ulrich, Raku, Raku Ch1. So it's 5 and 2. Obviously that should work. -5 should be 3. What if we divide 6 and 2? It's no, really. Wow, that's wrong. 6, 3, it's -1. That's completely wrong. Okay, never mind. But I really like this one. I like it because the person thinks differently. That's really cool. Going back and going forward to Arne Sommer, solution number 1 of the first task, and here we have again unit. Here Arne really likes this, and there's an additional Boolean flag to print some result. Sorry. Here and here. But let's look at what this function does. So first, well, not really first, but one of the first things to do is to take the absolute values, and what this is, negate. Well, count probably is the result, right? But this thing, so yeah, basically it's the need to negate the result if the original signs are different. Negate the result, yes or no. Okay, so while this number is bigger or equals the second number, we just subtract the second number and increment the number of subtractions. If negate, then we make the result of the opposite sign and count minus minus. So, and if this left number numerator is non-zero, then we decrement the result, like to get -3. But again, I'm kind of worried about the case 6 and -2. CD Arne Raku LS Raku. What is the event? Let's look. No, let's look here. Div int. Is it some description? No, it's just a different name, I believe, right? Okay. Let's run it. Raku Ch1 Raku. Number 5, number 2 should give the correct value. what if about number 6 into 3 and minus 62? Bam! Minus 3. That's correct. Wow. That's cool. That's cool. I was worrying because of this. But why? So, yeah, because this loop potentially ended like one step before, right? Or not? Let's try. Negate result, yes. So we subtract 3 times. Why do we have count n equals count equals 1, 2, 3? Then we negate and m apps. Yeah, I see. Now I understand this. So this m apps, it's not the initial number, it's basically the reminder after the subtraction. Then it's perfectly correct. This is the perfect solution, right? So we subtract the number a few times, and we will, and if we still have something left in m, then we have to move one step back to the left side of the axis. Right, Athanasius, go to solution of the Raku solution of the first task. What we can see here, the function m, which takes 2 integers, defined integers, dividend and divisor. So these are the terms, I believe. Not like numerator and denominator, which is about fractions. That's correct. Non-zero integer, where n? Yes, it's non-zero. So yeah, this is the comment that I mentioned earlier, that you don't have to compare it with 0. Then quotient, so the result, right? Backslash. Okay. If number is non-zero, then you do something. Otherwise, it just return 0, right? And for the number where we have to make some work, numerical ratio, which is what? So you're not allowed to use multiplication, modular operation, and division, but you're allowed to use logarithm and exponential functions. Okay, well, yeah, formally that's correct and that's allowed. But I would say this is really a nice trick. So so what is ratio? So it's a logarithm minus logarithm and exponent. So basically it's about the sign. This is about what this is. So what if you will have 2 numbers? Raku, my m is minus 5, okay. What? My m is 5. My n is 2. And this stuff gives us 2.5. But that's the result. Okay. So, and so you move it to like an exponential space and make the calculation there, and in that space division actually is subtraction and multiplication is addition. That's now I really find the beauty of this solution. Although I think that like logarithms and exponentials and exponents are kind of forbidden here, but they are not. And in that space, would you move the numbers there, you will just get, you can just use plus and minus, and you will get the correct result after you come back to your linear scale. And here we just check if the number should be negated, and we're using the floor or the ceiling function. Yeah, that's kind of, again, I wouldn't say that it's cheating, but it's using the power of built-in functions, which I think was not the purpose of the meaning of this task. But it's formally it's completely correct. I even want to run this function from the command line cd utter Raku chair 1 5 and 2, right? 5 2 minus 5 should mean minus 3, minus 6 minus 3, and plus 6. Yeah, definitely it works. Oh no, wait, it's not. Why? So let's my m is 6, let my n be 2, right? And if I will do this operation, what I will get there, blah blah blah, that's the, yeah, because this is not the Raku fractions, so it's just floating point operations. So probably we should use round function here, something like this. Well, yeah, that's the potential improvement of this solution, but the solution itself is interesting, but it breaks as soon as we go from integers to floating point numbers. Colin Crane, Raku 1. The solution, it's big. Numerator, denominator. So we knew from this solution that the correct terms, I believe, are the dividend and divisor, but it's not that important here. What is important is that here we compare, yeah, we disallow 0, quotient floor, divide to floor, numerator, denominator, floor, and we just print the result. So the main action happens here. But before that, let's look at this function, absolute, the number and the flag to negate the number. The flag can be rewritten. Okay. Why? Just because we need this. So that's the custom absolute function. Return number if it's positive or 0, and return this sum if it's negative. So the main action, divide the floor. Numerator is copy. Again, we are going to, so you see, so the difference between is RW and is copy is that here you modify the value in the outer space. Where are we using this function? Here, negate. So you see, so this is kind of the second return value of the function, welcome to the world of Fortran. So we modify the argument of the function and we use it later kind of as a result of the function, as the second result. But okay, and here we cannot change the original value outside of the program. So if we'll call this function here, so this variable will not be changed, and it can't be changed because it's another argument. But okay, so remainder, quotient floor, negate. So the flag negate is false by default. Remainder absolute, so we take the absolute values, and see, that's the trick. So if it will be negated twice, then there's no need to change the sign in the end. And if it will be negated once, like only in one number or only in another number, then we'll get true here, and probably, yeah, there's a separate branch to do something for negation. Let's look at this a bit later. But first, the do integer division of two positive values. So yeah, basically that's the well-known thing. We just subtract the number as many times as we can before it gets too small, the first number, and count the number of attempts, and convert the floor for negative results. The negative of the floor of x I, the ceiling of -6, this yeah, so I believe does Perl Perl, does Raku can do this? For example, my number is 2 and 5 or 2 and 4. Can I do it like this? Floor sailing. The format is for Raku. Okay, so let's run Raku floor sail. Sorry, you cannot use these, but I really like these characters. I wonder if they are somewhere in the documentation. No, no way. Really, but they should be there. That's the way Raku thinks about the source code. So that's the Raku philosophy, to have this as the operator. Okay, so it doesn't work, but we will notice that this can be added to the code. Right, going back. So quotient is so basically the negation. We saw this already, this pattern here. How to change the sign, but I don't understand why you can just omit the 0, because it's the same. It will be the unary operator instead of binary minus, right? It's not forbidden at all. And quotient floor minus minus, if there's a reminder, we saw this already, and we know that this should be correct. So I even will not run this function because I believe this is correct. Okay, the next solution, Raku number 1. Raku number 1, dividend divisor, correct terminology used here again. Negative, that's the exclusive. No, so that's bitwise operation. Of what? What is this? Is this? What is this? What type? Yeah, like 5 less than 0. It's false, right? And this is bool, so we can like take 2 booleans, are false and true, and that's true. That's bitwise, right? True, bitwise exclusive. It's not bitwise, it's just an exclusive OR. Sorry. But that's the, because yeah, that's short circuit exclusive OR. It's the short circuit exclusive. There's no about bitwise. Okay, so I was confused. Okay, so absolute values, quotient, which is the result that we will print. We just subtract as many times as we can, and if it's negation, and if there's something left, we just subtract another 1. And you see, so this is what I meant, that you don't have to type it 0 minus something, you can just type minus. Okay, but let's run this solution. cd Jaldar. No, where am I? I'm not here. Jaldar. Raku ls ch Raku ch 1 5 and 2 minus 5 and 2 minus 6 and 2. Right, that's correct. Good. Going next, Javier number 1, a solution with a test, done testing using test module. That's nice. We are taking 2 numbers and we are trying to, and we are going to modify it according to the signature is copy trait tells us about that. And again, there are like 3 quadrants at least. If they have different signs and none of them is 0, then we like add the flag to negate the result and negate the result. Okay, so yeah, we just keep the sign here, we put it from the number to some additional flag. The same here for the second number, and if they finally, if they're both negative, we do not keep this sign, it will be 0, and we will just negate the initial numbers. So, and while the first number is bigger than 2, then subtract. There's no need to like explicitly put it twice, like minus equals is, I think, the better pattern. And we increment this. And again, if it's negative, I believe the same thing here can happen, but I'm not sure because we already saw that the solution. So city Javier, Raku 1. How do we take parameters? We don't take this, right? Oh my god, we don't take these things. You just run it and you believe it. What if I change here and I will say like 6, give me 6 here and give me 6 here. Run. Oh no. Do we see? What do we see? Okay. 6, 6, 6, and the results are the same. -2, -3, +2, -3, +2. Let's add some printing here. Instead of return, we'll just say right, and I will remove this, I will remove this, I will remove this, I'll remove this, and right, and here I will just add something. Yeah, indeed. So it's the same number as 2 minus 3. If I will, yeah, because yeah, it looks like hard-coded values, but obviously they are not. Like, okay, let's make it 106. Yeah, it's 106. It was 106 divided by 2, and we got an incorrect number. Right. Okay, so this is incorrect. So it's -53. This is correct. This is not. Okay. Next, the next solution by Lauren Rosenfield. Raku. Oh no, sorry. Too quick. I'm going back. Recap. And the solution, Lauren. Number 1. Yes, so 2 numbers which we're going to modify. We restrict the second number not to be 0. The negation flag is true or false depending on NSC, so there's no space here, but there is space here. Why? Then we, you change the, that's the pattern. That's the pattern that we should really see in action. So there are 2 numbers. My m is 5, my n is 2, and then we say mn. So what we are doing here, I even don't know how to use it, like group 4. So for every number, every variable here, we take this topic variable and we assign to this an absolute value. So basically, to test this, you probably need to do it like this. Let's see how it's done. LS Raku group 4. 5 and 2, that's correct. Wow. I believe if we can make it like this, because this assignment probably we can replace and put it like this. That's amazing if it will work. And that works. Wow, that's nice. I really enjoy looking at this. Okay, then quotient, and while this is the first number is bigger than the second number, we decrement the first number, we increment the counter, and if it was necessary to negate, we print this. But again, I believe that this solution will print us -2 for the division of -5 by -2. So let's go by Loren to Raku. Raku 1, 5 and 2 is 2, -5 and -2 is -2. Yeah, this is yeah. Oh, stop it, that's wrong. And that is wrong. Why? 8, 3. Okay, yeah, that's probably this one should be like equals, or maybe. Well, yeah, I believe this one will fix it. Let's, but I'm not 100% sure that it will fix it. Equals Raku, right, and this is right, and this is -4 instead of but that's obvious because there's nothing to do about this situation. And finally, if it's, that's 4. Did we break the original one? No. Okay, so I fixed the solution, right. Going to Mohammed and Var, Raku number 1. Raku number 1, a solution in version 6D. So here's the default value is -5 for the like more weird situation which can happen. Here we restrict the number to be non-zero default. So see, so it's really nice feature. So there's the type restriction, there's the named parameter indication, there's the where clause, and there's the default value. A lot of things in one item for this signature of this function. Then with printf. Why printf? Just because we want, but I wonder why do we need actually printf in Raku? Because we can just interpolate in the variables inside the string, even this one. So just put it in a pair of curly braces and. Okay, so we can move to the function itself, natural div, which takes 2 numbers, where the second one is not 0, and then we set the sign first to nothing, I believe, and then depending on the sign of the input values, if it's less, then it's minus, but only if the second one is of different sign, and vice versa. So the sign is just minus, and the thing is that how we can use this sign. Let's look here at the end of the program. The sign is here, and it's just printed as a string. So it's either an empty string if nothing happened here, or just a dash as a text string. Okay, then we take absolute numbers again, and finally we make a loop for what is this loop about? So it creates for yeah, as many times as this value of n, and we make subtractions and count the attempts, and as soon as we either reach the end, or if we made the number small enough, we break the loop. And then if there was sign, if sign was not empty, then we increment the result. So for example, -5 divided by 2 will be like will be 2, then we increment, it will be 3. So we increment, but because we print the sign as a text string, so we don't care about like the direction of this. Nice. Let's run it. Raku 1 p6. Yeah, so it's a default, and if it's 5 and if it's 2, then it's right. And for example, if it's 8, it should be 4, and it's not 4, and now it's 4, but it's incorrect. This will not change anything, and this will be plus 3, which is not exactly the same what we need. Okay, nevertheless, let's go next, and the final code that we will look at is Roger's solution number 1. Solution number 1 is about division, so we make some tests, all positives, all negative, and partially negative. And the divide function takes 2 numbers, dividend dividend and divisor. If it's 0, we cannot do anything. First the sign is 1, and then we check the quadrant and set the sign. Actually, yeah, that's interesting. So the sign, we negate the sign of the existing value, but yeah, we can just assign it to -1 here on the right side as well as here. No, I'm wrong. So here we can do that, but here these ifs are not connected, so they run one after another. So this one actually will depend on the result of this one if the first condition was true. Then we start to collect the result here until, well, while the first number is bigger than the second one, we can subtract, and in the end, as soon as we have a negative sign, why not just compare it with 1, I don't know, with -1, then we negate it, and if there's something left, then we decrement the result again. So this looks as an extremely correct result. Roger, Bell, West, Raku, and solution in Perl 6, P6 I mean, are number 1. Everything works, yeah, but again, I'd like to take a look at some other. So I'm interested in what I'm interested in 8 and 2, in -8 and 2, and finally -8 and actually 8 and minus. So this one is -8, then this one is 4, and here it's -4, and here it is 4, right? I believe this one will be correct. Raku 1. Expected 4, got 3. Okay, 2. So expected 4, got 3. So if we divide 8 by 2, we get 3. And so here it's everything correct, right? 8, 2 gives 4. 8 minus 8, 2 gives -4, and -8 minus 2 gives +4. But here in these cases it's 3. So this is not the case for that. And then the error happens probably again, like we already saw this. I'm not sure that it will work now, but let's try, why not? So while this one is more than or equal, yes, I fixed this solution again. And that's the end of the first part of week 66. So don't forget that there's the second part and there's a separate video. You can watch it later. I hope you enjoyed this. So thank you very much. See you next time.